So here, again, children, let me strongly advise you, since I allow you to bring a piece of note paper with you, you can write yourself little notes on a piece of paper. And the best way I found to do that is actually get a piece of homework paper. And then it's already separated into spots, and you can go for number 14, remember to do this, or remember to do that. You said 14? How come I don't get 14? So 14, solve by inverse operations. Don't be fooled by the wording of that. Solving by inverse operations is just how we've been told. That means don't solve by inspection, but actually do the problem. So Madison, here's the deal. 0.8x equals 1.2. What type of problem is that? What type of an equation? It is 0.8 times x equals that. So the opposite, the inverse of multiplication is division. So that's what you would do to solve that. Divide both sides by 0.8. You might have to actually do that out. 1.2 divided by 0.8. Move the decimal, bring it up. Is 1. You get 40.5. Inverse operations. That's how we solve all equations. You always do the opposite. But some division one, you multiply, subtraction, you add. Sometimes you do a plethora of those things. Alex, yours was which one? Is this the one?
14 here.
Oh, perfect. Hey, number 10. So my notes for 14 on me would I write, hey, do the opposite. It's probably going to be close to that. Number 10. Is 10 not on this? Yes, please. During the holiday sale, the store discounted all items 1/3. What is the discount on an item? All right. If you go into a store, and let's say you're buying a shirt, let's say it's Dick's, or let's say it's Kohl's, where they mark things up like 1,000% and then they reduce them by 1,000%, and you end up with their huge sales actually paying what you should pay anyway. But this shirt is $19.95. That's the price tag on it. And it says they're discounted 1/3. On the sales thing, it has a sign that really says 1/3 off, because that's what you're getting off. How do you find out how much off you get? You want to know what 1/3 of 1995 is. What is, when you say the word of, 1/3 of that is multiplication. So you're just going to take, and you can't change this to a decimal because 1/3 does not work out as a decimal. You really have to do it as a fraction. But if you take 1/3 of something, what are you actually doing? You're just dividing it by 3, cutting it into 3 equal parts. It's 1/3 times 1995, which means you're dividing 1995 by 3. Now notice this is the discount. This isn't the sale price, but they don't ask you for the sale price. It's going to be $6.65 discount. So the price you'd actually pay is what, $13.30 or whatever. But that's this much off. Again, Kohl's, you go in there and every shirt is $80, and then it's how much off? 50% off, and then it's $40, and you're like, really? It's too much. Still $40. That's why you go to the clearance rack where it says 80% off, and then you get like something for. It's just me. Make you nervous.
Number 6.
6. So again, kids, problem number 10. What would I write to myself? It's probably going to be multiplication tomorrow as well. Multiply, fraction. Number which one? Maggie, 6. 6. 6. I know it is. I was just trying to meander my way there. Sorry. 6. 6. 6. Really? Starting to get frustrated. Draw the line through 2, 1 and negative 2, 3. What's the slope and the y-intercept? All right. I'm just checking to see if you're paying attention. How about this one? I should give it a grade 1. It's because I keep slide with it. The ratio of flour to sugar for the banana bread recipe is 3 to 2. If 3 cups of sugar are used, then how many cups of flour are needed? Anybody know what I would say to do on this one? Draw a Kayleen ratio box. And the first column is your, the first column is your ratio. This is your actual. What are you comparing? Flour to sugar. And what's the ratio of flour to sugar? 3 flour, 2 sugar. The actual recipe calls for 3 cups of sugar, so that goes here. How many cups of flour are needed? Now this one doesn't work out as nicely as one would hope, because hopefully you could say, well, 2 times what is 3? Because you'd multiply 3 times that same thing. Doesn't work out, so what are you forced to do? You're actually forced to do it out using what? Cross products. In other words, 2 times what number equals 3 times 3? You just divide by 2, divide by 2. Your answer is 9/2, which is 4 and 1/2. Is that the answer I said? I would even accept 9/2, by the way, if you're wondering. Again, when it doesn't work out evenly like this, really your best bet is you gotta just do cross products. 2 times that equals that. And remember, children, don't let this confuse you. You can't cross cancel when you have equal fractions. You cross cancel when they're multiplying each other. If this was a time sign, then you could cross out the 3's and you'd be okay. But if they're equal, you can't cross cancel. That's only when they're multiplying. Any other questions on that one? Logan, speech.
I still don't understand how you got that.
Which part? You don't know how I got the ratio box? You do know how I got that? Or you don't know how I got this?
Yeah.
Alright, when you have equal fractions, Logan. Oh, come on, little thing. Where are you at? Give me something to work with here. If I have, so you understand where I got this though? Yes? There's a little thing in math here, Logan. If you have equal fractions, when you have equal fractions like I have here, or supposed to have here, when you multiply the diagonals, you get the same number. 2 times 4 is 8. 8 times 1 is 8. So when you come up with something like this and it doesn't, and you can't just go like this and say, well, 2 times what is 3? You have to do what we call cross products, which means you multiply the diagonals. 2 times n has to equal what 3 times 3 is. So when you do that, you get 2 times n equals 3 times 3, which is 9. It is now an equation. How do I get the letter n by itself? Divide, this is multiplication, so you do the opposite. Divide by 2, you divide by 2, 9/2, or 4.5 is your answer. We've been doing these for a little while. If this would have been a 4, everybody would have been happy because it would have just been times 2 times 2, but it's not. So you have to kind of do that as cross products. Okay, Ron.
7.
I love 7. Favorite problem of all time. Ricardo drove 15 miles in 20 minutes. What was his rate in miles per hour? Here is the key. Miles per hour. What does that mean? That means this. The word per is a fraction line. So it is miles over hours. Or miles divided by hours, if you like. So if that's the case, how many miles did he go? He went 15 miles. Here is where people get confused, though. He did it in 20 minutes. That, unfortunately, is not in hours. So you have to figure out 20 minutes is how much of an hour? It's a third of an hour. Now, this might confuse you. I'm going to write it like this, but you have to remember this is just the division sign. So really, rather than looking at it like this, write it like this. It is 15 divided by 1/3. And how do you divide by 1/3? You flip and multiply and multiply. It becomes 15 times 3/1, which ends up being that 45 that they were asking for. 45 miles per hour. If it would have helped, and again, you can't turn it into a decimal because it's 0.3 repeater. You have to leave it as a fractions. Note to self again. You know, this is division. Write it out as a division problem, not as in a fraction form. Kayleen? Another way, by the way, for 7, just maybe this will help you. I'll get to your 4 in just a second here. You could have sketched this out and probably got the answer, children. You know in 20 minutes, this person went 15 miles, right? Well, in another 20 minutes, they would have gone how far? 30 miles. So in an hour, which is another 20 minutes, 20 plus 20 plus 20 gives you the hour. They would have gone another 15 miles. So in an hour, they would have gone 15 miles 3 times, which is 45 miles. I suppose you could think about it like that. I'm sorry, which one?
4.
4. Is that on this page? Of course it's not. It's over here, isn't it? 1, 2, 3, 4. Again, I would be writing some of this down. A coin is flipped 3 times. What's the probability of getting heads at least twice? And here's your deal with that. This is what I write on my paper. You're flipping a coin 3 times. So the probability of getting a head at least twice would look like that. And really, in order to do that, you really need the sample space. Was that what number 3 asked you for?
Yeah.
Okay, to do the sample space of that, let's do that, because once you have that, it's probably easy. You would do this. Here's your first flip. Your first flip, you can either get what? A head or a tail. Okay? After you flip once, on your second flip, okay, if you flip a head first and you flip again, you're going to have 2 choices from there that you can either get a head or a tail. If you flip a tail first, after that you could either get a head or a tail after that. That's your second flip. So if you're only flipping twice, your possibilities would be head, 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 tail, tail, head, tail, tail. But you're flipping a 3rd time, which means you got to go 1 more branch on your tree. Off of each one of these, you can get a head or a tail. And then your sample space is, you have to follow the tree all the way down. You could either get head, 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 get head, head, tail, head, tail, head, or head, tail, tail. That's the first 4 possibilities, starting with the head. Tail, head, head, tail, head, tail, 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 head, or tail, tail, tail. So that's where your sample space comes from, all of those options. Head, 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 tail, head, tail, head, head, tail, tail. And then, starting with the tails, you get tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. Now, once you have that sample space, the rest is pretty easy because it says, how many do you get a head at least twice? Well, looking at the ones we have, how many have at least 2 heads in them? 1, 2, 3, and this one, 4. All the rest of them only have 1 head in them. So it's 4 out of the 8 different possibilities, or 1/2 of the time, you should get at least 2 heads. Note to self. More. Okay.
How do you do number 20?
Number 20. Number 20 is a good one, I suppose. Maybe it would help you if you wrote the top of it out like this. This is 36. X squared is x is x times x, and y cubed is 3y's times themselves. So if you're looking at, this is this divided by this, how many times is 9 going to 36? 4 times. So this crosses off and leaves you a 4 on the top. 1x crosses off with just one of the x's on top. So that leaves you with 1x. And 1y crosses off with one of the 3 y's on top. So how many y's does that leave you with? 2, which is y squared. So your answer, when it all simplifies down, is 4x y squared. You can do the step pattern. Go back the other way. Does that help?
Yeah.
Logan?
I don't understand how I got 15.
15 or 11? 15, I'm guessing is on the top of this page. Which one?
18.
Number 18, not 15?
Yeah.
So 15 I'm sure is worth going over. Well, if I were going to say, here would be the trouble spots in this one, because you have to do exponents first, so we got to simplify all the exponents. 1 to the 4th power is not 4, 1 times 1, which is just 1. Got that one right? 2 to the 3rd power is 2 times 2 times 2, it's not 6, but it is 8.
That's right.
2 times 2 is 4, times 2 is 8. 3 to the 2nd power is not 6, it is 3 times 3, which is 9. 4 to the 1st power is just 4. And anything to the 0 power is, ladies and gentlemen, 1. Doesn't matter what it is. It could be a million to the 0 power, it's still 1. And then adding them together, 9, 18, 22, 23. So usually people, this is where a lot of people go wrong, and this is where a lot of people go wrong. Some people go wrong on those because they think it's times, but it's not. Taylor? 8? Number 8, children. Oh, look at that. Printed on a 1-gallon milk bottle was the measure 3.78 liters. About how many liters is a half a gallon of milk? So, Taylor, here is your gallon of milk. I'll tell you what, let's actually try to draw it like a gallon jug. What does that look like? You've got this little thing like this. This comes up and there's a handle over here. This. Here's my gallon of milk, right? Are you a 0.5%, 1%, 2%, what? Whole? What kind of milk do you drink? Or don't you drink milk? You don't drink milk? 2%. So, Taylor, on this gallon of milk, it says this thing is 3.78 liters in a whole gallon, correct? Well, they want to know, you want just half of the gallon. How many liters would a half a gallon be? You're just cutting 3.78 into 2 equal parts. It's just dividing. And again, the book put, and I think, yeah, and again, I don't know why they said about how many liters. I don't know why they just did how many liters. 2 goes into 3 once, into 17 8 times. So wait, did I do that wrong? 2, 17, 8 is 16, yeah, 18, 9. The book had 1.89, but I agree with you since it said about 2 would be fine. Half a gallon is 1.89 liters. Or 2 if, well, ma'am.
How do you do 15?
I was hoping, did we already do 15? Should we have done 15? Yeah, probably. Again, people struggle with this, and I'm not 100% sure. What am I going to tell you to do first? This is what I do. I don't do Alien. I always circle the different terms so I can see them. And they get split up by addition and subtraction signs that aren't in parentheses. So this is a term, this is a term, this is a term. You need to simplify those first. In other words, get them down to just one sign because two signs is not a good thing in our world. This one you can't do anything with, it's just -3. This one is two negatives next to each other. A negative times a negative is really what it is, which means, Madison, it actually turns to positive. Two negatives, an even number of negatives next to each other, whether you think of them as subtraction signs or negatives, that makes it a +2. And if you have a positive and a negative, or a negative and a positive, you end up with what? Positive or negative? Yeah, one negative makes the whole thing negative. Two negatives make it positive, three negatives make it negative. And then after this, it's adding and subtracting. This is no longer multiplication or anything. Okay, if you have 3 negative signs and you have 2 positive signs, 2 of those positives are going to cross off the negative to give you a balance of a -1. And here I have 4 more negatives. Nothing crosses off. I have 1, 2, 3, 4, 5 negatives. The answer is -5. I have $3. I get 2. I still owe somebody 1. I owe somebody 1. I owe 4. I still owe them 5. However you want to look at it. It's going to be a negative. Just remember, when you add 2 negatives together, you get a bigger negative. When you multiply 2 negatives together, you get a positive. I'm talking to myself. BK? The answer? 314 centimeters squared. Logan, sir?
I don't understand how I got 5.
Did we do number 5? I swear we did 5. Did we not do 5? Maybe there's 5 in the other class. A 50-question test contains 20 true or false questions. The rest are multiple choice. What's the ratio of true or false to multiple choice? Alright, so I don't know if you necessarily need to do this, but we can. You split this box up into a test. You're looking at true and false. You're looking at multiple choice, and if you add those together, you get total questions, right? So how many total questions were there? How many were true and false? So that means how many multiple choice did there have to be? The ratio they want is true and false to multiple choice. So you want true false questions over multiple choice. How many true and false? 20. How many multiple choice? 30. There's your ratio, you just need to reduce it. 2/3 should have been the answer to that. 2 to 3, or 2 to 3. What did you have? Did you put over 50?
I must have misheard you because I got 2/3.
Did I say 2/3?
I thought you said 2/4.
4 halves?
Yeah.
Interesting. Landon?
I'm getting ready to do number 17.
17 could be my favorite of all problems. As soon as I find it, I'll tell you what it is. 17. I don't think I did do 17. At least there's nothing written on it. Number 17, like a broken record, what am I going to tell you if you made a mistake? Probably one of the things you did wrong was, Alex?
Not in order of operations.
Yeah, order of operations say that you had to multiply first. Did you multiply first? Okay, that would be a note to self on number 17. Landon, I would put in big fat letters, order of operations, multiply first, because you need to take 3/4 and multiply it by 4/3, which is what this is, which makes it pretty simple because what is 3/4 times 4/3?
1.
1. And 7/6 minus 1, which is 6/6, is 1/6. Absolutely.
What was number 11?
Number 11, ladies and gentlemen, 62.8. It was just straight centimeters. Circumference is just the distance, it's only centimeters. Area is cutting something into square units. Ryan, Edmund, what was it?
Yeah.
Brooke, what was it the last time when you asked? 314 centimeters squared. Cameron,
That would be 15.
Who?
15.
Is that over here? Must be. What is the area of this figure? Gibran, did you cut it into two pieces?
Yeah.
So you've got the area of the rectangle plus the area of the triangle. And again, if you did something wrong, it's maybe in the area of the triangle. What is the area of the rectangle, Gibran? 8 times 6 is... Are we on this? 48, did we say that? Yeah? Gibran? Are we on the same thing? 8 times 6, 48 for the rectangle? And then we got the area of the triangle, which formula for area of a triangle is 1/2 base times height, correct? How do I know what the base and the height are, Gibran? I can't hear you. Say what? What's she say? No. I don't believe so. You can find all the measurements of this without the Pythagorean theorem. We're not looking for the perimeter, are we? If you're looking for the perimeter, you need to know this, but I already know what the base and the height are. They're the two that form the right angles. The height is right here, it's 6. The base, unfortunately, goes from here to here. It's not 12, but it is how far? It's 4, because 8 plus 4 gives you 12. And then you multiply that by 1/2, which any order you want to do it, 24 cut in half is 12. Area is inches squared. Oh, I'm sorry. 12 is just the triangle, and then you have to add that to the 48 to get 60 inches squared. Ryan Connor trying to get brownie points. But thank you nonetheless. Caleb's book is closed. Did you get them all right, sir? Most of them right? Caleb got half of them right. Just send that into the speaker up there so I can record it. Nobody else has any other questions on any of this? In other words, I will suspect that on Thursday / tomorrow / whenever we have this. How are you going to remember this for 2 days? Somebody, how are you going to remember? Oh, look at Taylor says I got my notes. Math is difficult. Nobody else has anything else on any of that. So let it be written, so let it be done. We'll now officially push the stop